Alright, we're continuing 4.5 today. I want to first start with a review of last session. We're starting solving two types of equations. Well, we managed to finish only first part, exponential equations. You have some exponential expressions embedded in the equation, and our first trick is, if you are lucky and the numbers and terms are convenient, you try to raise both sides into power of the same base, such as 125 is 5 cubed. 5 cubed equals 5 to the 2t plus 5. Cancel 5, set each other equal. We're all done. In the first two questions, we were able to do that, but in these questions there were no way we can raise 68 into power of 3, and we just switched to a whole different idea using a much better tool called logarithm. We took logarithm of both sides with a base of your choice, but you either choose the same base with this guy, or log base 10, or log base e, we call natural logarithm, shortly ln. Alright, and we've done that same thing here and there. And the last thing we finished was, I think, this one, right? We were about to start the second half, which involves equations directly with logarithms. You see the logarithms on either side? Okay. We start off with the easy types. What do I mean by easy types? You have one logarithm on each side, okay? And you have a bunch of other stuff inside. Look, one logarithm on the left, one logarithm on the right. And if you're lucky to have such a case, so this is, I call this a fully prepared dish. All you need to do is chop it up and eat. Alright, this is ready to serve. How do you eat it? Is this. You first take out one logarithm from each side. That's what this property says. If you have one logarithm on the left, another logarithm with same base on the right, you simply cross out this and set x equal y. That's what I'm doing. So these logarithms just serves a purpose to distract you, kinda. The real equation here is 3w plus 23 equals 7 minus w. It's that easy. Piece of cake, right? So let's solve this now. Again, 3w plus 23 equals 7 minus w. And I'm going to bring minus w to the left simply by adding w to the right. I want to bring the number to the right, and I guess we are going to subtract that number, right? And what is the total? 3w plus another w makes 4 of them. 7 take away minus 23 is minus 24. No. Yeah, no, of course not. 16. Okay, and the last thing we're going to do is division by 4. 4 it is. And, alright, we got it. There you go. Okay, one thing I need you to do, and this is not optional, okay? Check your solution, please. You're safe. I'm sure you're pretty safe in this question, but sometimes in the later questions you may get multiple solutions, and several of them, some of them may be fake or may not satisfy the equation. How do I check it? Just you don't have to check all the way. Just enter that quantity into logarithms and see the logarithm inside of the logarithm is positive. That's all you need to check. It needs to be more than 0. If you get a negative number inside, logarithms cannot be computed for negative values. It's wrong answer, it's wrong solution, okay? So when you enter this, do you get any negative numbers inside here, for example? W is minus 4. What is 7 take away negative 4? It's positive 11, right? So we are good there. How about here? 3 times minus 4 is minus 12 plus 23. Positive 11 as well. It's a match. This is 100% right. Check solution. Alright, so we have number 8. The solution is minus 4. And usually you expect to get decimal solutions sometimes. When you may need to approximate it, but here we were fine. We just got a whole number. You don't have to approximate that in the second part. Any questions? So what is the first trick we learned? Once you have logarithm on left and right, cross them out. But what's the catch? They need to match in bases. Base B must be the same. If this is 6, that's 7, won't work. Okay? Alright, what's the difficulty here? We're comparing to previous question. The fun is over. The real stuff starting. What is different? Yeah, don't tell me ln is new. No. Yeah, logarithm changed to ln. That's obvious difference. Instead of log base 7, you have ln's all over the place. But other than that, Shanta? Yeah. Instead of a single, this is single log, perfect. I love one log on the right, but this is 2 logs. Bad. 2 logs. I know some smart people do this. They love crossing out things. They drop all ln's, and you have only x, and then x minus 10. Where did it go? Okay, I'll do it again now. X minus 10, 9x minus 88. They drop ln's and set these each other. Completely irrelevant. Why can't we do it now? I mean, we just did it earlier. We dropped the logarithms, right? Right? Because you had only one on the left and one on the right. This is 2 versus 1. It's not fair. You're killing one person here and killing 2 here. Is it fair? No, you're going to shoot one from the right side, one from the left side of it. Okay? So, why shall we do that? Look, I'm identifying the problem here. We have just too many ln's here. You need to figure out a way to bring them together. And I bet you do know that. Where we've seen to bring 2 logarithms into one. What rule was that? What was that rule? Called, starting with a P. Product. Yes, product rule says logarithm of any base B of, they used UV back then. We used UV, I believe. Was log of each multiplied, correct? Correct, with the same base. This is the product rule. Agree? Yes. Austin is right. Although this is called product rule, you expect to see product somewhere, it's not here. The product is already there. This is a plus. Well, does it also work with ln's? What if these were ln's? Yes, it does work. So I'm going to use that to bring these 2 addition of ln's. Look, ln u, ln v is going to make some product of these two, or sum of these two, which way? So I'm going to combine them into single ln, but what do I do with the insides? Do we add them? I'm adding them, because it's addition. No, we multiply. We do not add them. We multiply like this. Here's the product. Happy now? What's that? Right. This is a one item term multiplying two terms. However, this is multiplying only one term, x and x. It's incorrect. So we need to have a parenthesis around this guy and distribute this out, okay? It's x squared minus 10x equals ln 9x minus 88. Now, is it a fair game now? Do you have a one guy on the left, one guy on the right? Do we? Is it fair now? Okay, let's kill them now. Here, one, both dead, and these babies are out. Right? X squared minus 10x, 9x minus 88. Now, this brings another issue. Unfortunately, this equation we are supposed to solve and that one we just solved are not the same type. This was a kindergarten question. It was all W's and numbers. Single W, no power. This is a square equation. We call it quadratic equation. You can't simply leave x alone here. What shall we do?
Take an x out.
We need to first set the right side 0. Well, you may go with take an x out. X is common here. But there is another x will be coming. How do you join that to the other group? So don't factor yet here. Yeah, you want to factor it. No, bring this x to this group, then factor it. Okay, actually bring everything to the left side. So I'm going to move everybody to the left. And it's going to make x squared minus x plus 88. Am I right? Hmm? Right, when I switch 9x to the left, it turns into minus 9x, correct? And this becomes positive 88. This is correct, but this one makes minus 19 of them. Alright. Now it's time to factor. However, this is a trinomial factoring. It's not just two terms. If it would be two terms, I would just take an x out and we would be done. But this is three-term factoring, trinomial factoring. The best way to do this is separate x squared as x and x, and guess two numbers whose product is 88, positive 88, but their sum, addition, will be minus 19.
Negative 8 and negative 11.
Negative 8 and
Negative 11.
negative 11. Let's double check. Minus 8 times minus 11 is positive 88. Perfect. When I add these two, they make 19. Great. Oh, we're almost there. And what is after this? We set each into 0 and isolate x. Right? 8 and 11. Two solutions. Agree?
8
Hmm?
won't work because you have to subtract 8 minus 10 and it equals 11.
Yeah. I was about to forget what I have to do. What is it we have to do always? If you especially get multiple solutions, check your solutions because one of them may be wrong. I'm glad someone did that. When I substitute 8, does everything inside makes positive? 8. This is fine, positive. 8 take away 10 is -2. Can you guys compute ln -2? No, no way. So immediately I go ahead and cross this out. False. How about 11? Maybe that one was also incorrect. 11 checks this one out. 11 checks that one out. 11 minus 10 is positive. Perfect. 11 checks this one out as well. I believe it's the right solution. Technically, I compute everything and see if it's really making equal, but we have about 25 people here. I don't think we have a mistake. 11 is the right choice. Correct, right? So, a finite set means you have a couple of solutions. All real numbers means infinitely many solutions. Empty set means no solution. We have one solution, so I didn't choose it. Yeah. Finite set, that's 11. Okay, ready for the next question? Well, don't read the solution method. This is the second method I'm gonna make soon. Okay? What is this? Oh, I skipped it. Well, yeah, because these are all boring questions, but you know what? I still want to do one of these, 11 or 10, because we have time. This is too easy. You will do this if I do 10. I'll do 10, okay? Just solve this, that's the question. Here we are. And I can even get this out. Yeah, we didn't use this one either. Okay, forget the steps, okay? Where's my solution? Problem here. Okay, let's solve this. What is the idea? Get 1 log on each side, right? That's our idea. We expect to get 1 on the left, 1 on the right. How many logs do you count here? Just 1. Just 1. I don't have the other side. Okay, I'm in trouble. How can I get a second log? I will show you. This is not mentioned in the book, but I will show you how to get the other log. Okay? First, we need to get 1 log isolated, right? 1 log on the left isolated, 1 log on the right isolated. So you already have 1 on the left. Why don't you get this isolated? Let's isolate this. What do I mean by isolate? I want to see only this stuff on the left. That means 7 and 4 must be kicked outside. So which one is going first and how? Subtract 4. Perfect. We'll get 7 log base 4 VW plus 1 equals 21. Next, get rid of 7. How? Divide by 7. Perfect. Now, I got 1 log on the left side. On the left. and completely isolated, great. But I'm missing the other log. All right, if you're missing it, can you make one up? Can you make one up next to this? Can you? For example, let's start building. What is 3 times 1? What is 3 times 1? 3 itself, right? Can I put 1 like that? Do you mind? Okay, now, do you know a particular logarithm that becomes 1, so I can attach next to 3? A logarithm that becomes 1. Okay. Any logarithm with any base, as long as this number matching, it's 1. So you can choose any base as long as this number match any number and that base, you can put it here because that's 1. I don't want to choose any base. I want to choose the same base so I can cross them out. Can I do this? Please tell me. Can I do this? Log base 4, 4. Can I put it right there like that? Yes, because this thing is 1. Okay? Okay? Now look what I'm going to do. I'm crossing logarithms. Do you agree? Can I cross out those logarithms? Don't write it down. You're buying everything I'm saying, so don't trust me. Can I cross them out? Can I cross one logarithm from right? It's even, right? Correct? One logarithm left from one logarithm right? Let's check out that property again. You can cross out one logarithm from left and right if they are completely on their own. If there is a number next to them, you cannot cross them out. If there is a 3 in front of them, in either side, no sir, you can't do this. Wrong. Back it up. Back up. As long as this 3 here, I cannot cross them. Then what can I do? Yeah. If you don't like this 3 standing in front, put it back in then. Remember, powers inside logarithms escape to in front. And if you don't like these criminals outside wandering around, you can put them back into jail, where to power form. Now take your magic pen. We can cancel them now because they are completely isolated on either side. And guess what we got? 3w plus 1 is the only thing left on the left side. 4 cubed is the only thing on the right side. What is 4 cubed, by the way?
64.
Perfect. And I will subtract 1. And how many times 3 goes into 63? How many? 21. Is 21 the right answer? You need to always double check. Yeah, it makes this positive. I'm sure it's the right answer. Okay? What is this method called? Do you know the name of it? Because I don't. It doesn't have a name. You can name it. Creating your own logarithm. Because you had only one logarithm. You isolated it. And this logarithm was missing. I made it up. It was my choice. I went with the same base and 4 so that it can become 1. This is making up a logarithm method. I'm going to show you the other method that the book uses, okay? But any questions on this one? If you have only one logarithm, you isolate it, make the other side logarithm on your own, cancel, pack first, pack this inside, cancel, get the result, okay? Now, here is the real deal. I'm going to show you the real method. Ready? It's actually this one. Let's read it and apply it to that question. First, given the equation, get the logarithms on one side of the equation. If you have two, you need to isolate them on either side. But here we have one logarithm, so I'm going to isolate that logarithm. Haven't we isolated already? So can I cheat? This is the isolated form, right? So I'm going to cheat this part, or I can redo it again. How do you isolate that? Subtract 4 and divide by 7. Okay? Subtracted 4, 21 divided by 7, 3. You got this. So up to this stage, we are the same. We are doing the same thing up to this stage. And after this stage, remember, I made my own logarithm, pack this 3 in, and cancel. That was the first method. Here is the second method. You got this, right? Logarithm 4 of some stuff equals to 3. We are going to change this into exponential form. How do we change this into exponential form? This is way back 4.3. Very first day of logarithms we introduced. I told you that b to the x equals a can be converted into logarithm. How do you convert this into logarithm? First day of logarithms, remember? Anyone? This becomes a logarithm equation with what? I bet this base b will be the base of logarithm, right? All you need to discover is where does x go, where does a go? Where does x go? Inside or outside? 50-50 chance.
Inside,
X inside,
like on the right of the B. Left of the equal sign.
here,
Yeah, right
here you
there.
mean, X,
Oh no, A goes there, my bad.
A goes there, yeah. X goes free. So when you put X in, you kind of lock inside logarithm. This guy was locked in exponential, it's not fair. X this time goes free to the other side, A goes inside the prison. That's how you convert, flip, remember? Now you're going to do this backwards. Change this into exponential. Read the base first. So you're going to change this into exponential. What is the base? Base 4. So you need to now flip these. Where does 3w plus 1 go? Top of it or right of it? To the right. Where does 3 go? Where does it go? Top. Please compare this. To this. What do you see? What do you see? They are the same. 4 cubed equals 3w plus 1. 4 cubed equals 3. So methods are kind of identical. Only this part, you're not making your own logarithm, you're changing into exponential. And this becomes 64, 3w plus 1, blah, 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 and you get w equals 21 again. Okay? The rest is the same. Which way you like better? Maybe you're used to this better, right? Because we've been doing this so many times. You prefer this way, okay? All right, now 11 is so easy. It's already been set up. Look, this is already a logarithm base 10 w minus 7 isolated equals 3 to the power 7. So all you need to do is change this into exponential and isolate w. You want me to do it? No? Yes? Okay. Let's do it quickly. Logarithm. What was it? What is it? W minus 7, 3.7. All you gotta do is change this into exponential. What is the base? I need to see the base. What is it? I can't see it. What is it? 10. It's 10. If you don't see it, it's 10. Then where does W minus 7 go? Where does 3.7 go? 3.7 to the top. W minus 7 to the right. Agree? And all you need to do is isolate W by adding 7 to both sides. The top question comes here. I got W, this thing, but how do I add 10 and 7? It's 17. How do I add these? You can't. Because this is an exponential form, this is a whole number. They are not like terms, they are not like items. So you cannot add them. This is your final answer. 10 to the 3.7 plus 7. Alright, you need to approximate this into decimal. They want in decimal, all you need to do is get the calculator and type this in here, or actually here. 10 raised to the 3.7. I don't want to go to Nigeria. There we go. Wow, that's too big. Did we type it right? Yeah, seems right. 5,018, 87, 23. How about rounding? It's 3, so it's going down. So we should be good. Yeah. Alright, we're back to our main question. Same deal. We need to isolate one logarithm on the left, one logarithm on the right, if possible. There is a clause. If possible. Okay. This guy is already alone. Do you see that? This is lonely already. How about this? Can you get this all by itself? In other words, can you get rid of this 2? Can you wipe it off somehow? Make it disappear. What's that?
Oh, because it's 2 plus the other one.
See it now, I can't. Yeah?
Oh, because if you do that, then it's 2 plus the one on the other side.
Yeah, we can't send it to the other side. If you send it to the other side, this time this guy won't be isolated. We want to isolate both. So if you send this guy to the other side, no. The only way you can make this disappear is if you can find out a way to bring it inside of the pack inside of this logarithm. I wish this was multiplication. If this was a multiplication, I could send it to the power like this too. Unfortunately, it's not. And I can't get that 2 out of my way. Actually, I know a way. I know one way, but I'm not going to tell you. Do you want me to tell you? You can make this Can I make 2 into 2 times log 6? Can I? Because this is 1. Send this here, and it makes logarithm 6 squared. And we have this guy, in other words, here. This is q, by the way. It's not 9q. Can I combine these 2 logarithms? It's a difference formula. Yes, it's called quotient formula. I can combine them into ratio of 6 squared q minus 35. And now the right side is lonely. Alone. You can cross out. You can solve this, but I'm not going to do this way. Because I know this is too tricky for you guys. Right? Is it too tricky? If you like it, yeah, do it. Solve it. Q equals 6 squared q minus 35, multiply both sides, solve it. But I just mentioned it. Smart idea. Maybe too smart. So what is the other way? Back up. What is the other way? Why don't we, look, these are same base. If they happen to be on the same side, maybe we can combine them like that way. These are now on opposite sides. Let's bring one into another side and they combine, hopefully. How? This is minus, just add opposite of it to the both sides. This way, we will have these 2 together. Let's see, it's too bloody this way. Q plus log 6, Q plus 35. Anyway, these are Q's, not 9's. Q. And this guy, what do we have on this side? Nothing but a number. Nothing but a number. Do you know where I'm going here? I'm going into this form. Means single log and only number case. If I have a single log and number on the other side, I can turn it into exponential and solve it. So I'm trying to get a single log here. How do I do that? This is product rule. Do you see that product rule? Addition of 2 logarithms can be made into one by product of insides. So these 2 combine into one log of product of these guys. I love repeating the same mistakes over and over. Where's the mistake?
30 plus 35.
Plus 35? This one?
Yeah.
No, that's not a mistake. This is correct because we only flip, when this goes to here, we only flip the sign in front of opposite, and I already did. You don't flip these guys, okay? They are the same. Now, the mistake is not here. The mistake is in the next line. Where is it? Parentheses again. I'm multiplying Q by 2 items. This is just single multiplication. We need a parenthesis and distribution. So it's Q squared minus 35Q equals 2. Now, do we have the situation of logarithm isolate it on the left, set it into number. Do we have it? If yes, we are ready to make this into exponential. Make base stuff equals stuff. If yes, is that so? Do you have only one logarithm on the left? Yes. Number on the other side? Yes. So we are ready to make this. What is the base? Base is, what is it? 6. All right, what is the top? 2. What is the other side? Q squared 35Q. Now how do we solve this thing? It's a quadratic. Again, over and over, we repeat doing the same thing the entire semester, right? We do some tricks and then we either get linear equations, no power around the variable, or square in the around the variable and some q, single variable and number. What shall we do? We will bring one side to 0, get trinomial, 3 terms on the other side, factor set into 0, and done. So this is 36. 6 squared is 36, right? Q squared minus 35Q. So which way you rather do? You want to bring these two to the left or only 36 to the right? Of course, this is easier. Bring 36 to the right. This is 0. Q squared minus 35Q. Is that Q? Minus 36. Now, who's going to break this into 2 groups? Yes. Negative 36 and 1. Right? When I multiply, I get this. Add, you get this. Perfect. Q is either 36 or Q is minus 1, but one of them is false. Which one is false? 36 or minus 1? Yeah, minus 1 is false because when I took this minus 1, logarithm is not computable. So it's just 36 then. Okay? And the last question of the day or homework is an interest question. This is actually have been observed before. You have seen this before, right? Interest question. Amount collected in your bank account after 10 years is computed by initial amount you make, rate, and how many times your money is compounded in a year. P1 plus Rn over Nt. We're going to take a look at this problem backwards this time. Earlier in 4 point somewhere, when we done this, initial amount was given. We knew how much money we were depositing in. We figured out how much it grows to after 10 years maybe. Now it's backwards. They have provided us how much money is this thing growing to, how much initially is put, but we don't know how long this money was invested. So earlier they gave us 10 years, now we don't know how many years. So you're going to solve for time, kind of solving for an exponential equation. So this is a good application. How long you need to keep your $9,000 to grow it into $11,000? Because this is great because some people have retirement targets. They say, oh, I have $1 million, I will retire. Okay? Well, you have only 100 grand right now. How long you need to keep to retire? You can compute how long. Maybe more than a century with that money, right? But, okay. This is just a preview. Think about this over the weekend. We'll start with this on Monday. Okay?